So today I will be covering Docker series part 6. If you want to learn more about Docker, you can subscribe to Sayam's channel and go and study about my previous parts. So today this is the guest created by me. I will be going through, and last time there was a request from everyone to give Docker security demo. So this time I will be giving the demo, and in part 5 I have explained all the best practices security which Docker security covers, and today I will be giving a demo on it. So I hope you can see my screen, and I will be using Ubuntu Playground of Katagoda. So you can use Play with Docker as well, but I'm using Ubuntu Playground. So before getting into the demo part, I would like to explain one thing from this document, docker.com. And before moving on to run these commands over here, that is docker content trust and docker pulling of the images. So before that, I would like to tell you what does docker content trust means. So if you also want to learn more about it, you can directly go to this docker docs and learn more about it. So what's Docker Content Trust? So this is the guide which provides an overview of Docker Content Trust and some quick familiarization exercises. So Docker Content Trust, what it provides, it is a strong cryptographic guarantee over what code and what versions of software are being run on your infrastructure. So it provides the authenticity of your devices, of your images, and so that you can run a proper code without any malicious code, meaning, and so that your images are free with the errors. So you can always use this Docker Content Trust. So Docker Content Trust integrates the update framework. If you want to learn more about this, so you can just click on this link and learn more about it. And what is the motivation behind Docker Content Trust? Is it is image provenance is critical for production. Obviously, if you are running your images in a production environment, then it should be free from all the malicious codes or the wrong codes, and it should be secure so that nobody can so that you are not pulling the wrong images. And distributed content should be signed. It should be a signed image. When you're trying to pull, it should not be an unsigned image. We will look shortly into it. And key compromise should be difficult. If you're generating your keys and all, it should be difficult so that nobody can enter into your images or your containers, Docker containers, and do something over there. So compromise resilience is important, and replay attack should be hard. Existing infrastructure is reused, and trusting Docker should not be mandatory. So I'm moving back to my guests. So Sayam can share my guest link with every one of you, and you can just do along with me all these. You can just run all these commands along with me. If you have any doubt, you can just paste on the YouTube channel, and Sayam is there to help you out. I will also help. I can also help after my session. So what we are going to do is now the first command is we are exporting to Docker Content Trust. That is one. So we are going onto the Docker this Ubuntu Playground, and let me just increase the size of the terminal for you so that it's easy for you to see. So I hope it is big enough now. So we are doing the content trust equals to 1. And now this is the command. Now moving on to the another command. So now what we have done is we have set the Docker content trust to 1, and now we will try to pull Nginx image from this command, docker pull. So let's go and run this. So what we are noticing over here is the image is pulled successfully because it is a trusted one. And now let's do one thing. Let's go into Docker docs again and try to pull this image. So let me clear the screen. And So in my last part, I have explained all about the Docker securities and what you should follow, what not. So today I am going just showing you demo on that. So I have told 34 plus Docker security things over there. So this is what you can see over here is you cannot pull this image because this remote trust data does not exist for docker.io clock. So this is not a safe image and not it is not trusted for the docker.io. So this is the reason you are not able to pull this image. But you were able to pull the Nginx because it was a trusted image by docker.io. So that was the reason for it. So now what we are going to do is we will look into the other. Let me increase the font size of this as well. And now we will see this command pretty nginx, what it will do, what you can do using this command. So let's see. So it will take a little time. So let me decrease little font so that there is a proper output and you can see what and all is happening. So if you go here, it will show the output of the images that are present on the server. So you can just see, have a look over here, what is happening. So you can use this command and you can have a look on the image. And this is what we are going to note from here is administrative keys for nginx. So these are the keys. So this is the main part of this command. So if you need your root key or repository key, so you can always run this command and note down this part from here. So let's exit out of this and I will increase the font again. Okay, moving on to the next part, what we are going to do is we will be seeing next Docker bench CIS benchmarking. So this is a very nice tool which shows all the best practices for your running Docker containers in production environment. And this is very nice tool. If you want to learn more about it, I will be sharing the link for this. So you can just go to this GitHub and this is really very nice GitHub repository and you can learn more about the Docker bench for security. So as mentioned here, you can just see this kind of output comes when we run this tool. We will be running this shortly. So the Docker bench for security is a script that checks for dozens of common best practices around deploying Docker containers in production, as I mentioned earlier. So you can use this tool for running your containers, Docker containers in production environment. This is really very nice tool and it shows that what are the warnings, what are the informations present on your servers, the images which are present on your servers. So it just scans around and just give you the best output. And the tests are all automated and inspired by, so you can just go through this link. And running Docker bench for security, so we packed Docker Bench as a small container for your convenience. Note that this container is being run with a lot of privilege, sharing the host file systems, PID, and just you can go through this and you can try running this command. So for now, I will take from here. So before doing that, what we'll do is we will set back the Docker content trust to 0 because then we will not be able to run this command. So we need to do this. So let's go ahead, paste it. So now let's run the benchmark command. So this is a long, pretty long command. So you can just go here and let's run this command and let's see what will happen. So let's go here and run. So why we have set it to 0 so that it can pull the images which are present on your server. So let's go ahead and run this. So, oh, I think there's a problem with connection over here. Not a problem. So let's see the output. I will run this again. So this is the output when you run this benchmark tool. And this Docker bench for security is very nice tool. I'm saying it again and again because I find it very useful in my production environments. So this is the information that it is providing and warning that ensure a separate partition for the containers has been created. So it provides with you with all the informations and warnings. So if you go here, you can see ensure auditing is configured for the Docker daemon. So it is telling you this is a warning part over here. And if you go down, so you can just have a look on here, and then let's go down a little. So it is showing the warning ensure network traffic is restricted between the containers on default bridge. I have shown this thing in my previous sessions, so you can just go and view my part 3 or part 2. So there I have mentioned these things, what is default bridge and all. So ensure the logging level is set to info, and this is passed. And ensure Docker is allowed to make changes to the IP tables. And then ensure AUFS storage is not used. So these are all the things that is passed. Ensure that the default C group usage has been confirmed. Ensure base device set is not changed until needed. Let's go a little down and just explore. So ensure daemon-wide custom SecCom profile is applied if needed, and ensure experimental features are avoided in the production. So I will just give you a link of security from Docker Docs, and you can just go and read more about these things, that what is this daemon wide custom SecCom or profile and all about all these things. So ensure that etc Docker directory's ownership is set to root. So these are the things. These are a few of the best practices that this tool shows you, and ensure that the directory permission are set to 755, or it should be more restricted. So instead of providing full access, that is 777, it is recommended to provide 755, or you can restrict more as per your requirements or project. So let's move on to the next pass thing. So you need to ensure that Docker socket file ownership is set to root Docker, and that is also passed. Ensure that the Docker socket file permission is set to 660 or more restrictive. So it depends, again, I'm saying it is dependent on your project. So you can set it as per your requirements. And then ensure that file ownership is set to root. Let's move ahead. So I think due to network, this session is closed. I will open again and let me refresh it. So moving on, you can learn more about this benchmark from this GitHub. I highly recommend you to have a look on it, and this is the command to run this, and you can just explore more about this benchmark thing. So let's move on to the next, that is Aquasec Trivy. So this is a very nice tool by Aquasec. It checks for the vulnerabilities in your Docker file or system. So you can just learn more about this using this github.com Aqua Security Trivy. So this is very nice. It provides you with a demo. So it is a simple and comprehensive vulnerability scanner for the containers and other artifacts suitable for the CI. So this is a very nice tool provided by Aquasec. So it shows you demo also over here, and you can just go through this link. I will share this, and this is how the output looks like when you run. We will run this now, and it shows like total 26, unknown 0. I will increase the font a little, low, medium 16. So it shows all the vulnerabilities that your image, your Docker file is having in the system. So if you want to learn more about this, you can just go go to here and learn. So Trivy is pronounced as Trivy, and it is a simple and comprehensive vulnerability scanner for containers and other artifacts. A software vulnerability is a glitch, flaw, or weakness present in the software or your operating system. So what does Trivy does is it detects the vulnerabilities of OS packages as well, like your image is having a if you're pulling your if your container is having Alpine, REL, CentOS, or whatever, so it will detect the vulnerabilities of your OS packages. And Trivia is very easy to use, and you can just install the binary and it will be ready to scan. All you need to do is for scanning is to specify a target such as image name or the container that you need to do for this. We will just have a look in a while. So it detect the comprehensive vulnerabilities. As I have mentioned earlier, that OS packages like Alpine, Red Hat, and Linux. These are all that's simple. It is very simple and fast, easy installation, very high accuracy. It provides very high accuracy and support multiple formats. So installation is as follows. You can just follow this document and go ahead doing these things. And now what to do next is let's go back to my guest and let's try running this. This is very simple command. So what we are doing is we are checking for Python 3.4 hyphen alpine. So let's do that. So it is pulling it. I will reduce font little after this command is executed so that you can just have okay, it's looking good. So these, if you see over here, is this is full package and it is showing the vulnerability in each of the. So let me reduce little font so that it is little clear. So so this is how it looks. It is very easy to install and it will tell you about this Python 3.4 Alpine, and these are the libraries bzip, and these are the issued vulnerability IDs associated with this library. So this is very clear over here. I think it is very simple to understand, and I just like this tool a lot. So it states you the ID as well, so you can just see what was there, what was the bugs, what was the issues, and with this version, and you can just play around with this tool and you can just see pulling the other images. So for now what I have done is I have pulled this Python image, so I just recommend you to go through and check for other images, and you can just check for the IDs and for which library the issue was raised, and you can see the version is also provided by this Trivy tool. So now let's move on to the next part. So we have installed Trivy, we have seen the Aquasec Trivia. You want to learn more about it, please go to this GitHub link. And now I will just tell you, if you want to install download a Docker file safely onto your system, what and all you need to do. So you can always add these commands. I will share gist also with you, and these are the node versions, and SHA is 3, so this is 4th, and it is 5th one. So this is how you need to store in your Docker file these commands, and after that what you need to do is you can safely pull your so let's create one Docker file and let's try doing that. So I will just copy from here and let's try to pull. So I have explained over here also that what it does is, so let me clear the screen and let's paste here. Oh, sorry. Let's create an image. Sorry, file. So let's do Docker file and just insert. So this is how you can just go ahead and create a Docker file, and you can safely download within the Docker file. And let's read out the explanation which I have written over here. The first command obtains the signing key for Nginx, which is added to the key store, and the second command adds the Nginx package repository to the list of repository checked for the software. And after this, Nginx can be simply and securely installed with apt-get installed, preferably with a version number. So try to give the version number, and assuming no signed packages or checksum is available while creating your own is easy. So for example, to create checksum for Redis release. So let's go ahead and let's do this. So what we are going to do is we will be doing this for Redis now. Let's go. Okay, sorry. So I think this is not present over here. I have not pulled it. Okay. So let me okay. So now let's go ahead and run the further commands. Network is having issues. So so let me try to paste this in a notepad. I think it's not taking it properly. Okay. Two commands I have copied. So that is the reason. I think file. Let me do it again. Okay. So that one was coming over there. And now let's run that for the command. Software, you can add something like the following to your Docker file. So you can always try adding this to your Docker file, and then you can run, you can add something like this. So these are few of the security tips mentioned over here. Like you never run Docker as root, and try if you want to run Docker as a not non-root user. So what you can do is you can run this command, run group and hyphen r user group and user add hyphen r hyphen g. So this is the command. And if you want to run as a non-privileged user, you can just go and do run this command, run this. You can use the following thing, and so this is the image of Redis, and you can just go to the GitHub and check for this gosu Redis over there. So for the images present in the GitHub, you can just go and check for the Redis, and if you open the Redis image, you will see that it will be written that gosu Redis is there. So now it gives all the permissions to the Redis user, and then exit and replace the current shell with Redis and PID1. So now I will tell you how to do volume read only and limiting restart, limiting CPU, and limiting memory, limiting the capabilities. So what we can do is we can run the following commands if you want to do such things in your Docker. So you can just go Docker read only Debian, and you can just visit my gist and try running these few commands over there. And if you want to run this, you can just set the load to 2048. So this is the command. We can just go and try executing this command. Okay, over network. So what it is doing is it is setting the load to 2048. So this is how it is happening. It has first pulled the image amount slash stress and then this thing. So CPU will be, this will be the stress. And now let's try running this command for the memory swap. So this is the full command. Okay, I should clear the screen and then I should. Okay, but in this Ubuntu playground, I don't think we can. Okay, it's doing. Okay, fine, yeah. So successful, it was successful. So this is how you can set. This is one of the best practices before running into your production environment. And this is how you can limit your memory, your CPU and capabilities. So now let's have a look to how to uh, change the ownership. And you can just try running this. And now let's try to run this Docker file with a non-root user. And let me clear the screen first. If you have any doubt, you can reach out to my Twitter handler, I_Saloni92. Today network is not with me, so I'm trying my best. Yeah, so from CentOS you can do, and what it is doing is it is adding a new user Sam with the user ID 887, and we are adding the user 887 Sam over here, and we are changing it to non-privileged. So this is how you can do. And now let's try building this Docker file. Okay, it is showing invalid reference format because this C should be in lowercase. So let's go ahead and put this in the lowercase. And now let's try building it. So now it will be successful, and the user will be. So let's it is pulling. It will take a little time. So till then, let's copy the next command from gist and keep it. So yeah, almost done. So it is adding 8877 SAM, and it is successfully built. So let's clear the screen. And now you can see the user SAM 8877 with ID has been added. And this is the non-root image ID. And these are few of the useful links which I wanted to share with you. You can just go ahead, and I have taken references. I have studied from few of these blogs, and this is the Aquasec wiki from where I have studied. You can also go and learn more about these tools from here. Now I will hand over to Sayam. Over to you, Sayam. Thank you all for attending the session. If you have any doubts, you can post in the YouTube. I am there.
Okay, I think that was a really great session, due respect to the network. Uh, so the thing is, I really liked, how the example of Docker file. So I mean, you can see that that's how you actually create a Docker file with the best practice, and you define a non-root user and use that. And even that Redis example was good. So you create a checksum, and then you use the SHA, that's 16-bit, whatever that integer comes out to be, and then you can use it inside the Docker file. So inside the Docker file itself, you can pull the images securely. So obviously we use Docker files for our production ready environment. So you have your I mean, it's really important that we have Docker files, and sorry, we are able to pull the latest images inside the Docker file securely. So for that, it's important to use that SHA, some stuff over there. Also, Saloni, one request for you, that is that can you please share the gist? So, I mean, I really like gists, and you have really documented that well. So people can go ahead and use. So it includes the example for Docker Bench, Trivy, some of the other like capabilities, limit add capabilities, remove the drop the capabilities. So they are really good. And also, if you can include that Docker content trust documentation, the docs, that would be good for the viewers. So I hope you all enjoyed the session, and I'll now share my screen. And we have something else for you today, which is GitHub Actions. And let me share the screen. Cool. So you should be able to see the screen now, and I'll switch my camera a little bit like this. So if you're able to see the screen, give me a thumbs up in the chat. And I hope everything is visible as well. There's a bit delay, and I mean, there might be a bit delay due to network constraints. So sorry for that again. Okay, so today we are going to discuss Cloud Run with GitHub Actions. So this is what you asked for, and this is what here it is. And we have our Cloud Run today with GitHub Actions. I have a demo for you as well. So with that, let's first go through whatever I have prepared over here, and then we'll go. So basically, what we are going today on the high level is we'll be using our GitHub, and there will be a Cloud Run action that I'll be using. After that, there'll be a YAML file that I'll be creating. Inside that YAML file, there will be a lot of stuff which we'll go through. And main thing that we need from the GCP account perspective is the name, key, and the account. And so basically, name will be of the Cloud Run service that we have to run. Key will be the service account token, and account will be the service account itself. And then magically you will see that things get deployed to Cloud Run. So basically, what we are going to do is we'll be using GitHub capabilities, GitHub action capabilities, and deploying the same code that I demoed in the last time. So I created a Cloud Run, and I created all that stuff and deployed a sample application from my Git. So using the same GitHub repository, I'll be now using the GitHub Actions capabilities to deploy directly to Cloud Run. So let's see what GitHub Actions actually is. So GitHub launched GitHub Actions to automate the developer workflow. So GitHub Actions give you the capabilities. So it's something like like you commit the code. So maybe a developer commits the code, and the things get automatically built and deploy. So that build and deploy portion can be automated using GitHub Actions. There are wide variety of GitHub Actions that are already available, and people are actually realizing its worth. Like GitHub Action actually is it's really powerful if they are used if they're used in developer workflows. They are really very powerful. So here what happens is as a developer will develop the code, and we'll have a workflow. So the workflow triggers a lot of GitHub actions. So set of workflows will be defined in the set of GitHub actions will be defined inside the workflow. And one of the GitHub actions that we'll be using is Cloud Run. So that what will happen is, so this is a small developer I tried to create. I mean, it might not look like, but yeah, it's still a person sitting at a desk and pushing the code to GitHub. And then the GitHub Actions is getting triggered and deploying that same code to Cloud Run. So you can see how easy it is for the uh, I mean, for you or for a developer, in the sense to deploy the code to different set of environments. So you can also have different branches. So you can have your staging branch, you can have a development branch, you can have your production branch. So you can have a different set of branches, and on that set of branches, you can have specific set of actions. There are a lot of triggers for the actions as well. Like if you push the code to this branch, or if you what should I say? If there is a pull request, then there can be a certain set of action. Or if there's an issue, then you want something, a Slack message or something like that. So you can leverage these GitHub Actions. So Google Cloud platform has created a few GitHub Actions that can be used. Like Compute Engine is there, Cloud Run is there, GKE is there, I believe. Yes, yeah, GKE also is there. So you can use them, and you can build workflows on top of it. And as soon as you commit the code in certain branch, so people in your team want to collaborate, so some other person also pushes the code. So in the end, what you want is whenever the code gets pushed at the end of the day and in the master branch, so there should be a new release or a new version of Cloud Run that has to be built. So all those things can be readily achieved over here. So let's see. So yeah, I discussed already Cloud Run in the previous lecture, just to give you a maybe a recap, you can say. But yeah, the already the images. I mean, sorry, the video from the last session is there, where I have introduced serverless concepts, the very basic high level, like what serverless actually means with Cloud Run with the demo. So all these things have already been taken care, and it's already recorded. So you can go check that out on the channel. I'll post link after the session maybe. And but those who are very new, and I don't want to disconnect from here. So Cloud Run is basically deploying a container to cloud. So it's a managed service by GCP. So it's for deploying a container to cloud. So you don't worry about the infrastructure, they worry about the infrastructure. You don't worry about the scaling, they worry about the scaling. You don't worry about basically anything. So they'll give you the endpoint, and you can use your own endpoints, you can use your own URLs, and you can switch them back. Recently, on I very recently, I think 1 or 2 days back, or maybe three, a very new feature came out for Cloud Run, which is gradual rollout and rollback. I will share the documentation, but what that means on a high level is, so when you are so what happens is you have a new version of the app. So what you'll do is you'll build that version with that specific, maybe the GitHub commit, and you tag it. You run that particular stuff with the hyphen hyphen no traffic flag. So when you give a new no traffic flag and tag it as some deployment, so you get a URL that will only be for developer, and you can test your app. Now, once you have tested your app, what you can do is you can do a G Cloud Run services update traffic. So first you did no traffic, now you can do an update traffic, and you can do for the tags where that you give. Suppose you have given maybe tag A previously, so you can give value equal to 1, and then your traffic 1% of the traffic starts flowing towards the tag whatever you mentioned. Then gradually, when you feel like okay, 1% traffic is done, then you can do maybe 10%. 10% of the traffic, then 20%, then 50%, and then 100%. So what you have to do is you just have to have an automated workflow, or maybe you can do manually as well after your testing, where you give the update traffic my services. So I'll just write it down if you need. So you'll be having a G Cloud update traffic. So this is what you have to do, and then you have to give the service name, like A, B, C, the service name, and then hyphen hyphen to the tags, whatever tag you have defined, like maybe green, then the 50% of the traffic. So this update traffic and the tags that you can use, and once you give it 100, the 100% of the traffic gets routed to this particular the URL with the tag green or whatever you give over there. So that's the new feature that came out. I thought it would be very good that if I tell you, there's a very good blog written by Stern, and so he has already mentioned all the examples and all these commands, so I'll share that as well. So but I feel like it's really very cool feature to have. So they have added support for gradual rollout and rollback. Next, what we have is, Cloud Run comes in two forms. One is the regular Cloud Run, and another one is Cloud Run on GKE. So on the GKE, it is like you can customize the timeout because you have your Knative base framework. I have explained it in the previous video, and we'll go more deep dive maybe in future session. And you can also have GPUs. Uh, Yes, so that's a very high level, maybe 30,000 foot overview for Cloud Run, and you don't need to worry about that if you don't understand a lot of stuff over here, because today we are more focused on running our application on Cloud Run from GitHub Actions. So that's the main target. So we'll see the complete end-to-end setup, how it's done. I haven't done it. I have a fresh account that I have prepared, and I haven't done it. So let's see Cloud Run GitHub Actions. So Cloud Run is a workflow and that uses GitHub Actions to deploy the container to Cloud Run. So the steps involved, so we'll be creating a GitHub repo. So the repo is already there, and we are having the, okay, I'll use a highlighter. So we have the Git repo already. We have committed the code. We will create the secrets. So these two secrets we'll definitely create. Then we'll create this particular file. So in order for a GitHub repository to incorporate the GitHub actions, we have to create .github, then workflow, and then this particular YAML. And in the YAML, we will be having a lot of stuff. So we give the name, we give on push to master branch. What happens is, and then we'll give the environment variables that it have to pick. So we'll be having the project ID, the region, the service name, then the jobs. So what you want to do is, we have three jobs over here. One is set up, build, and deploy. So it will set up the GCP build and deploy. Then is set up the G Cloud CLI. So it will be setting up the G Cloud CLI using the service account key and all that stuff. So then the third one, so I mean, it's a lot of steps. I'll show you in the GitHub repo itself. So we'll configure the CLI like you do. Like basically, it has to run the G Cloud commands, right? So it is setting up the CLI. Then what we do is we build and push the image to the Google Container Registry, and then deploy to Cloud Run. So the prerequisite for this is a GCP account, and you should have the Cloud Build API enabled, and then you should have Cloud Run also obviously enabled. So these two three things should act as a prerequisite. Rest everything we'll just go over. And yeah, so that's what from the theory perspective, this is what I have. Like, that's what we are going to do. Yeah, please do give a thumbs up if you like this way of teaching, because like, I mean, I'm trying to improve it, and yes, suggestions are welcome. So let me know how I can improve this stuff. So let's see. And now, switching back to the demo, let me share my other screen. The network is too slow actually, so I don't know why it is too slow today. Okay, so you should be able to see the screen. Just let me go to Cloud Run GitHub Action. Yeah, you're able to see the screen, right? Please give me a thumbs up. I'll regularly check that. Okay, cool. So we are having a thumbs up. So this is the GitHub Actions, and the usage is pretty clear. Like, what you need is, you need a service account user. You should be a Cloud Run admin. You should be a storage admin, and I mean, you should not give a project admin role. You should give granular permissions. We'll try to be somewhat granular, but still there'll be wide permissions there because they are the pre-built roles that we're using today. But what I would suggest is you create your own roles with your own set of like customized what you call customized permissions, and then you assign those to the service account. We'll be using the not the very high level, but we'll try to use the minimum defaults what I mentioned in the repository. So this is where your actual GitHub Actions takes place. So the GitHub Action, it says that you download the SDK, the image is built, and then the deploy to the Cloud Run. Then you can see that you have your code. We are not going to use this code. We have our own code from the previous like previous time I ran. And then we'll be, yeah, these are the set of roles that we have to create. So let's not wait and let's start creating stuff. So let's create this role because this is actually needed. So, and give these permissions. So we'll go to our cloud account. We'll go to service account. It's slow. You have to bear with me because my laptop also got slow. I don't know for what reason. So we go to, okay, I don't know, man, what is happening? Okay, just be patient. And let's go to service accounts. Okay, I might reduce the brightness a bit. Maybe it is causing some of the delays. I'm not sure what is happening. So we are on, are we on the IAM? Yeah, we are on the service accounts page now, and we'll create a service account. And let's give it a name, Cloud Run. And or maybe just, yeah, Cloud Run. Any name is fine. For Cloud Run with GitHub Actions. Let's create this. Now we'll give a set of roles. So one is obviously the Cloud Run admin, and then we have to give storage. I was seeing somewhere storage was given. No, let's not give storage admin. Let's give a viewer. If not, then there'll be error and we'll fix it anyways. So let's give project viewer, then viewer, sorry. So let's give actions viewer, and then we need cloud build service account, cloud build editor, cloud build editor. We also need a service account user, service account and user. I think that's enough for the roles. So we might customize later, but I think that should be fine, maybe. But still, let's check. Let's give a small check. We have a cloud build service account, editor, admin, viewer, and service account. Yeah, we have enough of the roles. So let's continue over there. So it's updating the policies, and let us, yeah, I think it's done. We don't need to do anything. Let's create. Once it's done, we have to create the key. And show you the code as, yeah, I'll show you the YAML file so that you know what YAML file I have created. So I'm using the same GitHub repository, okay, which we used the last time. I'm not changing that. So this is the role that is there. So let's click on that. So there are no keys. So we have to create a key. We have to create a JSON key, and so that with that JSON key, you can authenticate with this user. So what I'll do is I'll quickly add the key, create a new key, JSON, and we'll create. Let's see, doing things from scratch might break. So I mean, let's see. Hopefully it works. But that's the flavor of live demos, right? That's why I love them. Test.json. Let's have them. Yeah, we can have them anywhere, but let's have it. Save. Yeah, we'll replace that. I already have that, but we'll replace it. Let's close this and let's open. I want to open this in a text edit. Oops. I hope this is the right one. Okay, let's open it again with the text edit. So we have this, we'll control A, control C. So what we have to do is we can't paste it as it is because then they won't be able to understand. That's how it's built. So we have to encode it to the base64 format. Sorry, I have used the decode. I'll use the encode base64 and encode. Yeah. So we'll encode this to the base64 format and let's do the encode. Let's copy everything from here. Now let's go back to our repository and let's go into the settings. So this is the repository. I go into the settings. I create two secrets. So I come down, I go to secrets. And in the secrets, you can see, right? It's slow. I know that, that it's slow. Oh man. Okay, so what we have is we have the run SA key. So we'll update it. So I did some testing, so it's already there, but no worries. We'll update to the newer account. So let's click on update. Meanwhile, I have some water. So we are updating the value now. We have already copied. I hope it was copied because it is. I'll not say again and again that it's slow. It irritates me. So here it is. We have pasted it. Now let's update the secret. Done. So this secret is updated. So another one, the other secret also, yes, definitely we have to update, which is the run project. So it has to be the project ID. There are ways to get project IDs, but we'll go with the simplest one. We'll just go to our project over here. We click over this small arrow and we get our ID. I double clicked. So we'll get the ID from here and I'll copy this. Control C, go back, update the project value. I mean, that's the two secrets that we need. Now, how we are using these secrets, let's see that. So we have in the code section, like I told you in the slide, okay, not in the slide, in the diagram, we have to create .github/workflows. And inside that particular folder, we have to create a Cloud Run YAML. Inside that YAML, let's go through each and everything. Now I'll increase the font so that you can see that. I hope you are able to see the big font. Wow. So we have a build and deploy to Cloud Run, on push to the master branch, and we are taking the project ID from the secrets. We are running against the central US Central 1 region, and we are giving the service name as Hello World Python. So it should create, ideally, theoretically, it should create a Hello World Python Cloud Run service in GCP against the project ID that I have given in the secrets. Okay, that was kind of a wrap, right? Now to the jobs. So we have set up the build and deploy. So what we'll do is we have a lot of steps. So first we'll check out. We have set up G Cloud CLI. So that is the standard. Like you have to set up the G Cloud CLI using the service account key and the project. We have to build and push the image. So we are building the image with the tag project ID, service name, and GitHub SHA, so that it's unique always. And then we are deploying the same GCR project ID, service SHA, and because it will change next time. And we are deploying it with the obviously unauthorized, so everything is there. So we are able to deploy, we should be able to deploy the services into Google Cloud Run. And that's it. That's I mean that's only a 44 YAML file, 44 lines YAML file, so it's not very high file. So you have to make a few changes for making it run to your particular workflow or your particular um, code that you have. So this particular repository, if you don't know, like if I explained already, like what is there in this repo, so you can check out the previous video. So it has just a simple Python file. So this is a kind of Python container, and it will. So I can show you quickly, but I mean, yeah, I don't want to skip anything. So, but yeah, the net is okay. So it's a kind of Flask that is there, and you have the routes, and you are running on port 8080, and you can skip the port also. By default it takes 8080. So I think we are done with this. Now let's go to actions and see what is happening over there. If it failed, then we have to see what happened. So we can see, okay, what we'll do is let's click on build and deploy to Cloud Run. Okay, so we have to push something to the master, right? So what we'll do is let's update certain code, or let's go here and let's rerun it. View the workflow file. I can rerun. Yeah, let's rerun the job, and let's see this run. Yeah, let's click here, setup, build, deploy. Let's see what is happening. Yeah, so we have the terminal. So it did set up the job. So it is running. Okay, it updated the property. Okay, the build has failed. Let me check why the build has failed. I think there is some cloud build API has not been enabled. Okay, I didn't enable it. That's sad. Let me enable the cloud build API. Let's go to cloud build API and we'll see if it's updated. I mean, if it's enabled or not. Yeah, it's not enabled. My bad. Sorry. I thought I enabled it. Okay, I didn't do anything, that means. So it's a completely fresh from scratch. But that's good, right? That's how we learn. Now what we'll do is we'll again try to rerun the flow and see if it's okay. Our API is enabled. So let's rerun this particular job. And let's see now if it's successful. Let's go to setup, build, deploy, starting the workflow run. And it did set up the job. It's checking out. Run means okay, it set up all the stuff. Now our main concern is the build one. We are not concerned with anything else actually. Properties are updated. Okay, it needs access to storage objects get. I think we gave that, right? No, storage objects get. Even this access is needed. Yeah, somebody told, right? I mean, somebody, it was written storage admin. I should have given that for now. Okay, let's go to manage resources or something like that is there. Let me just check. Manage. I am where it was. Manage resources. Let's add to this particular service account. I mean, actually the console is very slow, but I mean, you have to bear with it. I don't have any options. Come on, why it's not loading. Okay, okay, I didn't select the project only. Wow, great. For this project, we have service account, we have cloud run. Let's edit that. Let me add the storage admin itself. What was the role? Storage objects get. Okay, storage. Let it be for now. Policy is updated. Let's try to rerun the workflow again. Sit back and relax. That's what happens in a live demo. But we'll fix it. No worries. Checkout is done. Run is always fine. There's a problem with build. I don't know what's the problem with build now. Okay, so the build is happening. So it has created the stuff. The logs are available, and the tar ball has been uploaded. So good. We can celebrate that our authentications, authorizations, and our role, service account, all those stuff is in place. So that particular portion is in place. So build is done and deploy is in progress. So you can see in the build, it is, yeah, it is building the image. I don't know why it's not going up. Oh, damn. Hide this notice. Yeah. So you can see the Docker file has done its job, and it has successfully pushed the image to the GCR repository, to our Google Container Registry, and post checkout it also did the deploy. So you can see it deployed to Google Cloud Run Hello World service. So from this, it's clear that everything is working. Now let's go back to the console and see Google Cloud Run. So let me go to Cloud Run, or we can go from here as well. Ta-da, ta-da. I hope you all are there with me, and it's still not boring, right? Because the demo is there, it worked, and it deployed a sample application like the one which we used. But at this point of time, it deployed it from GitHub. I just pushed the code, and it deployed directly from GitHub to my GCP account. And I didn't even touch my GCP. I didn't even do anything. And it gave me a URL. So let's see if it's working. Awesome. Community. Hello, community. So our demo is working perfectly fine. So that's how, I mean, you can run, Google Cloud Run application using GitHub Actions. So you can have your cloud GitHub action and you can run it. So there are a lot of other GitHub Actions from GCP, like I was telling you, Google Cloud Run, Compute Engine, and Google Kubernetes Engine that you can use to deploy a static website, to deploy the containers we already discussed. And yeah, cool. It worked finally. Nice. So the repo is this. Let me paste the repo. I mean, if you want, you can clone it or you can do whatever you want.